Welcome back. In this lesson, we're going to look at compounds. So when atoms come together and chemically react, they're going to form other things. And those compounds can be explosive. You can cause a bomb, or they can turn into something that would float away and become a gas, or a solid that would fall to the bottom of the pond, or any imaginable combination of things. There's zillion, billion, quillions. And so we'll look just at the beginning lesson of this and try to make some sense of it. This lesson we looked at atoms, and atoms are the smallest part of elements. Those elements can combine, or the atoms of those elements can combine either with themselves or with each other. And when they do, they're going to form compounds. And a compound is a substance of two or more atoms chemically combined together that have unique properties. So for instance, hydrogen gas is lighter than air. It explodes and it burns. Oxygen gas is invisible. It is in about 20% of the air you breathe. It also burns anything. In fact, fire is a reaction of oxygen. That's why you have to have oxygen for a fire. When those two chemicals or minerals, gases combine with each other, you are going to have water. And water doesn't have the same properties as hydrogen gas or oxygen gas. Water is liquid at room temperature. You know what water is. So you have unique properties to water that's different from the properties of the components that water is made up of. So whenever a chemical reaction occurs and a new compound is made, you're going to make something new with new properties, new color, new density, new melting point. Everything that you can describe about it is different. The formula is simply the recipe. So when you have water, you've got two hydrogen atoms combining chemically with one oxygen atom. So H2O together is now water. It's a chemical combination. Na, which is sodium, and chlorine, Cl, come together to make table salt. Chlorine is a green poisonous gas. It was used as a bomb during World War I to go into the trenches and kill people. It's extremely poisonous. It's a choking smell. Sodium is a silver metal that's the consistency of cream cheese. You could cut it with a plastic knife, and when you put it in water, it explodes. So totally different properties. But when sodium and chlorine react together chemically, and by chemically, you're sharing electrons together, or you're stealing electrons from each other, and that's what a chemical combination is. We'll look at that later. Then you have something new. You have table salt, which is not green, it's not poisonous, it's not metal, it's not squishy, it doesn't blow up in water. It's totally new. It's a new compound. Now, the bonds that are formed between these electrons can be, there's three basic types of bonds. You have metallic bonds, which form between metals, where each electron basically goes on the outside of the whole metal and can conduct electricity. That's why metals make good wires for electricity. A covalent bond is when remember, valence means outside shell. Co means share. So the outside shell of electrons are being shared between two atoms, and when that happens, the outside valence shell is counting for both of the atoms, and as such, it's more stable. And as more stable, they will form a compound. That's called a covalent, where the electrons are shared. Okay, and then when you have a covalent bond, one of those covalently bonded compounds is called a molecule. So if you were to have two hydrogens and one oxygen atom, and they form a compound, and you only have one of those compounds, one of those H2Os, that's called a molecule. A molecule is the smallest component of a compound. Remember, an atom was the smallest of an element. while a molecule is the smallest of a compound. Now, it's pretty cool that when you have a molecule, you also have stuff going on electrically. Polar means that you would have a pole, and Earth has a pole. We have a north pole and a south pole. Magnets have poles, where you have a north pole and a south pole. So polar has a lot to do with whether something is negative on one side and positive on the other side, just like a magnet that has a pole. What you're going to see here is that electrons are negative, and the protons, which are inside the nucleus, are positive. And the positive protons are pulling on those electrons. Right? So that's why that they're at a certain distance from the nucleus. When you have a compound, you're going to have multiple sets of protons pulling on multiple sets of electrons. Okay? If you see here the picture, you have oxygen in the middle, 2 hydrogen on the end. The protons in the hydrogen atoms are pulling on the electrons. Well, but the protons inside the nucleus of the oxygen atom is also pulling on the electrons. If I were to say which one's pulling harder, I would look and say, well, there's 1 proton in the hydrogen nucleus. There's 8 protons in the oxygen nucleus. I would say the oxygen nucleus is pulling harder. And that's what is true. The oxygen's protons are pulling on all of those electrons more than the hydrogen atom's protons are, because there's more to pull. So it's like a tug of war where you have 8 guys on one side and 1 guy on the other. The chances are pretty slim. Well, what's going to happen is that pull on the oxygen is pulling those electrons closer to it. And so remember, each of those hydrogens donated an electron. So there's 8 electrons now, and they're going to be towards the oxygen. That means if you look over here at the red colored ball, it becomes slightly negative because all those electron negatives are being pulled towards the oxygen and leaving the hydrogens. Well, the hydrogens become slightly positive, the oxygens become slightly negative. That's called a polar bond, a polar molecule. And since poling means you've got positive on one side of the molecule, negative on the other side of the molecule, well, this can act like a magnet. Negatives can pull on positives. In fact, that's how dissolving works. When you have water and you pour a salt in that water, then the water is actually ripping apart the positive and negative ions inside that salt. Now, an ionic bond is not sharing, but it's pulling so much that it actually rips it off. So, for instance, in the sodium, chlorine is actually stealing one of sodium's electrons and putting it to itself. Well, chlorine has 7 electrons in its outer shell. If it pulls 1 more into its outer shell, it has 8 more into its outer shell. That's a negative. So what's happened is that chlorine is no longer neutral. It has 1 more negative than it has positives. Remember, the positives are the inside, and they're equal to each other. The negatives and positives are equal. Well, if it steals an electron, it now is more negative than it was positive, and so it's a -1. If sodium gets an electron stolen, it becomes +1. Those are now ions. You have a sodium ion, which is +1, a chlorine ion, which is -1, and now they stick together by static electricity. Positives and negatives will attract together, just like socks in the dryer will attract. When that happens, if you completely remove an electron to yourself and make an ion, then it sticks together by static. That's called an ionic bond. And that bond then will change the properties, just like I told you that sodium was a metal, a silver metal, and chlorine was a poisonous gas. Table salt, you know what table salt is. I mentioned metallic bonds. The electrons, the valence electrons of each of the atoms inside a piece of metal, like a wire, are not beside the nucleuses. They are delocalized. They're on the outside of the entire wire, and those electrons are free to move, and that's what's being moved in electricity. When you give those electrons a place to go by either plugging a wire into the wall or attaching it to a battery, then the electrons are free to move around, and that's how we have devices. Of how to visualize these bonds. An ionic bond is actually stealing an electron and becoming ions. Remember, ions are positives and negatives. Then they stick together, static electricity. Covalent, co means share. The valence electrons are the outside electrons. They're being shared. So that's how a bond forms. And then metallic bonds, the electrons are not around the atoms inside the metal, but are outside the outside of the whole wire. And that's why that it can be used for electric conductivity. A chemical reaction is when one of these compounds are formed. So either one of these bonds are formed. Either an ionic bond is formed by stealing, covalent bonds are formed by sharing, or metallic bonds are formed by getting rid of the electrons that are valence electrons. So this is an example. This is water being made. You have H2, which is a hydrogen molecule, O2, which is an oxygen molecule. So there's two oxygens together, joined together. Hydrogen, there's two hydrogens joined together. And you're going to see that I need two of those hydrogen molecules. That's a total of 4 hydrogen atoms. 1 molecule of water, or of oxygen, forming 2 molecules of water. So that is essentially the formulas. And then as you react two things together, everything on the left is called reactants. Everything on the right is called products. And as you react them together, you're going to have the same amount of stuff on both sides. It's balanced in terms of matter, and that is a chemical equation. And that arrow means produces. Okay, so that is your equation means equal on both sides. Same amount of hydrogen on both sides, same amount of oxygen on both sides, and then they form something. That's a product. Now, a mixture is when you put 2 or more things together, but they don't combine chemically. So if you put salt and pepper on a plate, you don't make something new. You're just going to have salt sitting there being salt, pepper being pepper, and it doesn't necessarily form a reaction. Just because you put 2 chemicals in a jar doesn't mean they naturally will form something. They will or will not, and by studying it, you can give an idea of whether something's going to happen or not. But a mixture is just 2 or more things together. So if you make Kool-Aid, and you've got sugar and water and dye and flavoring and whatever, that's not a new substance. That's just a combination of substances that are too small for your eyes to see. If you were to have beef stew, that's a mixture. There's carrots, potatoes, and meat and juice and whatever. That's all together. That's a mixture. So a solution is a mixture that's so mixed that you can't see it, like Kool-Aid. That's a solution. Beef stew would be a mixture that you could see the different parts of, so that would not necessarily be a solution. So mixtures are combinations that are not chemical reactions, and solutions are just mixed really, really well. Homogenized, I think is the word. The last thing here is going to introduce the idea of an acid. An acid is a substance that can produce hydrogen ions. And hydrogen ions that can be donated, just like the electrons being stolen to make something. In a chemical reaction, you can donate a proton, and it can go into a new thing and make something new. That would be an acid. So any acid that can donate a hydrogen ion to something else is considered an acid. A base is anything that can accept that proton.